Hello and welcome back to another past paper. This time we're going to be looking at October, November 2024, and this is variant number 1. Okay, paper 1, an hour and 45 minutes. Remember, no calculators are allowed on this or paper 2, and this paper, same as paper 2, is worth 75 marks, 50% of your final grade. So, let's have a look. Start off nice and easy. Question 1, question 2 will get 10 marks quite easily, quite quickly. The size, question 1, the size of a file can be measured using different units. Okay, tick one box to show which of these is not, okay, a unit of measurement for a file. A bit, yeah, a single unit, yeah, a bit. A bot, okay, but that's not, is it? A nibble and a byte. A nibble is 4 bits, a byte is 8 bits, so a bot with a tick is going to be the wrong answer. Okay, the size of a file can be reduced by compressing it. Okay, give 2 types of compression that can be used to reduce the size of a file. Well, there's only 2 types we really talk about in computer science, and that's lossy, okay, and lossless. Yeah. Okay. Give 3 benefits. This was 3 marks. You've got 1, 2, 3, so 6 marks to start off. Give 3 benefits to reduce the size of a file for storage and transmission. Give 3 benefits. Well, it's given us clues here, storage and transmission. So in terms of storage, and in terms of transmission, so start with storage, reducing files takes up less space, okay? Smaller, so faster to transmit. Okay, so it takes up less space, smaller, so it's faster to transmit. So that's our storage and our transmission. So what else? Well, we've done the obvious ones, so we've got 2 marks, but a more obscure one might be more likely to be sent via email as will pass size restriction. Okay, because most email systems, Google, Gmail, Outlook, have sort of a limited roundabout. I think Google Gmail is 25 gigabytes. So fairly big, but 25 gigabytes. And then you've got to go on and use sort of cloud storage and various things. So there is a limit usually set by mail service. So that would answer that last one. So 2 easy ones and then maybe something a little bit more obscure. Question 2. So we've got 6 marks. Question 2. A student has a smartphone. Identify 2 input devices that can be built into the smartphone. So what can we use to get things into the smartphone? Obviously, we've got a microphone. So we can record sound, we can record our voice into our phone. We can take pictures. We've got a camera, okay? Camera. Which could lead to sort of various scanner technologies. We've got a barcode scanner, you could argue, but that would be sort of software-based on the digital camera. Also things like biometrics, a touch, having fingerprint recognition is also deemed an input device. Okay, identify 2 output devices that can be built into a smartphone. Well, along with a microphone, we'd obviously have speakers. And then this is where you might struggle, an output device. But what you could say, and this is the same for the output in terms of touchscreen, and then you could argue the screen, because that is an output device like a monitor. So question C, the smartphone contains secondary storage. Explain the purpose of secondary storage in the smartphone. Okay, well, it's used to store files permanently until we delete them. Okay, it's also used for installing applications and storing. Okay, so installing and storing applications. Identify the most suitable secondary storage type for a smartphone. Well, the only two storage devices we need to consider would be SSD, solid state device, and HDD, a hard disk drive. So obviously it's going to be SSD. Why? Because it's got no moving parts. Therefore, it is more robust. Yeah. And less likely to get damaged if dropped. Okay. Also, because there's no moving parts, it is also quieter. Okay? Because there's no moving parts, there's no sound. Okay? Sound from the fan, but no sound from the SSD. Question 3. A user enters text into a computer system using a keyboard. An American Standard Code for information interchange, ASCII, character set is used to convert the text to binary. Identify one other character set that could be used to convert the text to binary. Well, there's two. There's extended ASCII, which takes ASCII from 128 characters to 256 characters. It's 8-bit rather than 7-bit. But the one I think they want in here, which would represent sort of millions of different characters, would be Unicode. Okay, Unicode. So, the character A is represented by the denary ASCII number 65. Okay, the character M is represented by the denary ASCII number 109. Convert the two denary ASCII numbers into binary. Okay, so what I'm going to do first of all is I'm going to go, and does it say anything about 8-bit? No, but we'll make them 8-bit because we generally use a byte of information. So I'm going to go 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. Okay, convert the two denary ASCII numbers into binary. So let's start with 65. How many 128s go into 65? None. How many 64s go into 65? 1. How many do we have left over? If we take 64 away from 65, we've got 1 left. So that means we have none, 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 1. So this first one would be 0, 1. 1, 2, 3, 4, 5, 1. 1 lot of 64 and 1 lot of 1. Now 109, again 128 doesn't go into 109. 64 does, but how many have we got left? Consider 64 taken from 100 would be 36. Let's do this. 109 minus 64. Yeah, would be 5 there, 45. Okay, 45 left over. So that means how many 32s go into 45? 1. So let's take away 32 from this. We've got 3, 13 left. 16 doesn't go into 13. 8 goes into 13, which means we've got 5 left. So 4, 0, 1. Okay, so that would be 0, 1, 1, 0, 1, 1, 0, 1. Okay, so that would be our two numbers there. Yep. Now we need to convert the same numbers into hexadecimal. Now, the nice thing is because I've got this up here, it's a lot easier to convert binary into hexadecimal. And I'll show you why. I'm just going to get a different color. If I take these, if I take these numbers here and I split them into 2 nibbles, on this side, I've got 0, 1, 0, 0. So let me just rub this out and split them into 2 nibbles. So I've got 1, 2, 4, 8 again. So now on this side, I've got 4, and I've got a 1. So the number there would be 41. And on this one, I've got a 4 and a 2. So that would be 6. And here I've got an 8, a 4, and a 1. So that would be 8, 9, 13. But I can't have 13 because that's 2 digits. So if we think about hexadecimal as being 10 equals A, 11 equals B, 12 equals C, and 13 equals D, then the answer there would be, let's rub that out, 13 would equal D. Okay, would equal D. 14 would equal E, 15 would equal F. Okay, so 6D. So that's how I would do it. Split it into 2 nibbles. Okay, makes life a lot easier. Otherwise, if we've got 65, and we want to convert this into, so let's put 65 in here, just do the first one. If I go 1 and 16, and then I've got 2, 5, 6, I've got to say, right, how many 16s go into 65? Okay, so 16, 32, and 48, 4, 1, 64. Okay, so 2, 3, 4. So in 65, there are 4 lots of 16. 4 16s equals 64, and then there would be 1 lot of 1. Okay, 4 times 16, 1 times 1. That's how you could do it the other way. Yeah, how many 16s? How many 16s in 65? How many 16s in 109? In 109, there would be 6 lots of 16, and there would be 13 left over. Okay, that is it for that. Okay, part C. So more of the same, really, but they just take more of the same, but they just take a little bit of time. So this time we've got 0, 1, 1, 1, 1, 0, 0, 1. Convert the ASCII number into denary. So let's have a go. Let's do this. 1, 2, 4, 8, 16, 32, 64, 128. So I've got none of those. I've got a 64, I've got a 32, I've got a 16, an 8, and a 1. So I know it's going to be an odd number to start with. So if I go 64 plus 32 plus 16 plus 8 plus 1, I should get 96, 102, 112, 120, 121. Okay, do it that way. Convert the binary ASCII number to hexadecimal. Binary ASCII number into hexadecimal. Well, I've just done the same thing there, so I don't quite want to duplicate in this. If again, let's show you, I'll split this, rub these out, go 1, 2, 4, 8. I've got 7 on this side, and I've got 8, 9 on this side. So the answer should be 79. Yeah, 7 lots of 16, 9 lots of 1s. Okay, 9 units and 7 lots of 16. A logical shift, a logical right shift of 2 places is performed on the ASCII number 0111101. Give the binary number after the logical shift of 2 places is performed. So 0111101. And I'm going to the right. So I'm going this way. Okay? So 2 places. So let's start, yeah? So 0. So I'll fill these in with zeros. Yeah, and then I've got 1, 2, 3, 4, and then that 0 becomes there. So that is my new number, which equals 1, 2, 4, 8, 16. 16 plus 4, 28, 30. Okay, so, but that is the answer. Let's put that little magic Yeah, that is my answer. Okay, next, a lot of binary questions. Yeah, oh my word, more. The character T is represented by the binary ASCII number 01010100. Okay, let's see if we can zoom in a bit on this so you can see it a bit better. Yeah, the character T is represented by the binary ASCII number 01010100. The character lowercase t is represented by the ASCII number that. Add the two binary numbers together using binary addition, give your answer in binary, show all you're working out. Okay, so binary addition. Have I got plenty of memory? Yes, I have. Okay, 3 marks for this. Wow. Okay, so let's put these numbers in. 0, 1. And we'll try and get these lined up underneath each other. Yeah? 0, 1, 0, 0. And then we've got 0, 0, 1, 0, 1, 1, 1, 0. Adding them together. Let's do it like this. You could convert these. You could convert these numbers and then add them together and then turn them back into binary if you wanted. But I'm going to do it this way. Okay, we can't, what you've got to remember in your head, we can't have anything more than a 1 or a 0. 1 is the biggest number, 0 is the lowest number. Okay, it's 2-bit. It's a base 2, sorry, not a base 2 number system. So 0 and 0 is 0, 0 and 0 is 0, 1 plus 1 is 2, but we can't have 2, so we go 0, carry the 1, pop that in there. 1 plus 1 again, 0, carry the 1, 0, carry the 1. Now we've got 3, 1, 2, 3, we go 1, carry the 1, and that would be our number. 1, 1, 0, 0, 1, 0, 0, 0. Okay? Hopefully, yeah, let's end the question 3. That is it for those first 3 questions. Lots and lots of things to do with binary. Okay, a change of question, a change of shirt. A company, question 4, a company decides to create a network for its devices. Okay? So it's going to create a network. All the company devices are within a single room. The employees, that's important, the employees will need to use their devices to send data to each other and share files. So they're all going to be sat in a room. We don't know how big the room is, but assuming not standard size, normal, a room. Yeah. The company decides to send data across the network using packet switching. I suppose it doesn't decide to, it just happens. It's how it works. Okay, so an employee sends an email to another employee. The email is broken down into packets. Describe the structure of a packet of data for the email. Okay, so we have packets. It contains a header. It contains a payload. And it contains a trailer. The header as the destination IP address for recipient. Okay. The payload is the data, usually about 64 kilobytes. Yeah. And the trailer contains, it's usually some kind of error checking. Okay, so that would be, I've drawn it, yeah, destination of IP address, the recipient, the data, the payload, and the trailer. It also contains packet number, okay, the number in the sequence, because it's broken up into sort of many packets, and these have all got to sort of join together at the end. So it needs to have a number so we know which packet it is and which packet it joins to. Okay, so that's that one. Let's have a little look what's next. Another 4-mark question. The company decides to use parallel full duplex data transmission to send the data across the network. So full duplex, you've got user, okay, and it's sending signals in both directions. Okay? So data can travel in both directions across the network, across multiple lines. Yeah? So data travels in both directions across multiple wires. Therefore, it is faster. Okay. Now going back to the previous part, we're all in one room. So data doesn't need to travel long distance. Okay. I think that will do. I'm just going to put in brackets both directions at same time. Okay. I think we might only get 3 marks if I didn't put that in. It's traveling, because it's full duplex and not half duplex. With half duplex, it'll send it one way, will wait, and send it the other way. With full duplex, it allows for them to be traveling at the same time. So that's fairly important. We'll get us that extra mark. Okay? Give 2 drawbacks of a company using this method of data transmission. Well, basically, what I've written there, we're looking for the opposite. So because it's traveling in multi-directions, yeah, it may become this, maybe you've learned this word, may become skewed, okay, where data doesn't arrive at the same time, okay, or when it's expected. And because of that, there's more chance. Is more chance of errors. Okay? It's to do with the multiple wires. More chance of errors, something called cross talk to multiple wires. Okay? Give one other method of data transmission the company could have chosen. Well, you've got many, haven't you? If we do the complete opposite, we've got series and we've got, in one direction, simplex. Okay? Series simplex. Or we could go half duplex. We could go parallel half duplex. Yeah, we could go parallel simplex. Series half duplex. We just mix the terms together. So series or parallel, simplex, duplex, half duplex, and do it that way. Okay, nice and easy, 1 pointer. Right. Question 5. A central processing unit, CPU, performs the fetch, decode, execute, the FDE cycle. Give 2 names, or give the names of 2 registers that are used in the fetch stage of the cycle. The fetch stage of the cycle. These are the things in the MDI. These are the things in the CPU. So you've got things like the program counter. I'm going to put the 2 most common ones, the AR and the MDR. Okay? Memory address register and memory data register. Okay? So, but we could have had the control unit, the CU, and we could have had the CIR, the current instruction register, but I would say they're probably the most common ones, okay, which you might be more familiar with. But yeah, CU and CIR you can also include. Describe what happens at the decode stage of the cycle. So with 3 marks, we'll look at three things. Describe what happens at the decode stage of the cycle. Well, number 1, the CU receives instructions. So we decode it. We fetched it. Now we decode it. The CU receives instructions from the MDR. Okay, from the MDR. the data register. 2, data received via data bus. Okay, so it's traveling from the MDR to the CU via the data bus. And then the CU, number 3, the CU, this is what we're doing, the CU decodes the instruction. There's other little things you can put in there as well, but I would have thought, yeah, CU receives the instructions from the MDR, the data is received via the data bus, travels along the data bus, the control unit decodes the instruction. Okay, that is just the decode stage. Okay, don't get confused. Don't start sticking in memory address registers in and whatever you, and the accumulator. We're not there yet. Okay, the CU needs to decode it before the thing can be processed. Okay, before it can be executed. So give one register in the CPU that is used in the execute stage. Well, I've just mentioned it, the accumulator. Accumulator, I think that's how you spell it. The accumulator. Okay, that's what I would use because that's doing the mathematical calculations, the ALU. Yeah, ALU. The arithmetic and logic unit. Our favorite part, where we've got some missing word. Oh, no, it's not a missing word one, it's just circle some words. Buses are used in the CPU to transmit data through the fetch, decode, execute cycle. Circle 3 buses that are used in the CPU. There's a data bus, there's an address bus, and there's a control bus. Okay, easy as that. None of the other values are buses. That's 3 marks. Wow. Okay, for 2 marks, a user changes their CPU from one with a dual core, yeah, and a clock speed of 2.4 gigahertz to one with a dual core with a clock speed of 3.5 gigahertz. Explain the effect this change will have on the performance of the CPU. Well, it's faster. But what does that mean? In terms of it can perform more instructions per second. Okay, I think that'd do. Yeah, it's faster in terms of it can perform more instructions per second, increase performance. If we're linking it back to the question there, performance. Okay, it's faster in terms of it can perform more instructions per second, increases performance. A few 1 markers for question 6. State. Okay, 1 mark, 1 word. Okay, a computer programmer uses assembly language to create a computer program for an embedded system in a washing machine. State what is meant, for 1 mark, state what is meant by an embedded system. So, but it is a computer system, yeah? So, a computer system designed, so a little bit like a washing machine, it's designed to do a specific thing, i.e. wash clothes, yeah? Different program settings, but it's designed to just do that one specific thing. It's designed to do a specific job, okay? Give the name of the translator that will be used for the program. A translator, you've got 2 different translators. It's either assembler, compiler. But I think in this case, because it's doing it this way, give the name of the translator that will be used for the program, you would assemble it. So assembler. Because we're using assembly language. Assembler. Okay? C. The washing machine needs to display error codes on a small screen if there is a problem with the washing machine. The error codes are stored in binary. The binary numbers are too long to be displayed on the washing machine. State how error codes could be reduced in length to be displayed on the screen. Change to hexadecimal. You can even change to denary, but hexadecimal is going to make it considerably shorter. Okay? Give one benefit to the programmer of using assembly language to write a program. Small set of instructions, easy to learn. And because there's only a small set, it's faster to run. Execute. Okay? That's what I put. That's above and beyond. Yep. Okay. And then, oh, part E, we've got a big question. 6 marks. So, and they want 3 different things. The programmer uses an IDE, okay, a little bit like Python's IDE, to write a program. A built-in translator to convert the program into machine code is one way that the IDE helps the computer programmer. Describe 3 other ways the IDE can help the programmer. Okay. Error, check the code. Fix bugs. E.g. syntax errors. Okay. Just check if the battery's still working. It can auto correct and auto complete code. Okay, and something called it can color identify different things. E.g. variables. This is something called pretty print formatting. Okay, so things like if you're doing a loop, it's going to, when you do a return, it will automatically tab to the right place, so you can put your loop in until you tab back out of it. So yeah, pretty print. Oh, good morning. Good morning. Pretty print. I will be a second. Okay. There you go, one for you. Identify one function, one other function of an operating system. Hang on, have we done it? Is there a question for operating? Oh, I missed it. Oh, here we go. Question 7. A computer is an operating system. The operating system provides several functions. Tick one box to show which of these is not a function of the operating system for 1 mark. Does the operating system manage files?
Yeah.
Does it provide an interface?
No.
No?
Does it? That's
You told me.
GUIs.
Yeah.
Yeah.
But does it handle interrupts?
Yes.
Does it load? Is it loading the bootstrap? I'd say no. I'd say it manages files, it provides an interface.
Mm-hmm. Yeah.
You're clicking on icons and things. It's handling interrupts if there's something wrong with the printer, it's run out of paper.
Yeah.
Loading the bootstrap is something, it's the BIOS, that's the actual setting of the
BIOS does.
Exactly.
Yeah.
So loading from the bootstrap. Okay, identify one other function of an operating system. Describe the purpose of this function. What's an operating system do? What does an operating system do? It allows multiple users to use and access the computer. It inputs and outputs, talks to input and output devices, using drivers to control them. It manages applications. It deals with multitasking. You name it, too. So I'm going to put handles input and output devices. Uses drivers to communicate with them. E.g. printer interrupts. Yeah. If a printer is run out of paper or there's a printer jam, the operating system's using the drivers to communicate and say, actually, we need to pause this and call and create an interrupt So it handles input and output devices. It uses drivers to communicate with them, e.g. printers, okay? And obviously mentioned there the use of interrupts. Give the name of a set of instructions, here we go, B. Give the name of a set of instructions that are provided to the operating system to allow it to run. Oh, we had that question earlier. Okay, let's go back. Here we go. This one, loading the instructions using Bootstrap. So the one that was rejected here is the one that I'm going to put into this here, Bootstrap. Okay, the set of instructions that are used when we're booting up the system. Okay. Now then, question 8. Draw and annotate a diagram to show how a payment transaction is made using digital currency and blockchain. Oh my word. Okay, well we've got a person here, yeah, with their tablet. Okay. So, user wants to send digital currency. Okay, so that's step 1. So user wants to send digital currency. So I'll put to user 2. To user 2. So user 1 wants to send digital currency to user 2. So user 1 creates transaction on device with wallet details of user 2. Okay. User 1 wants to send digital currency to user 2. User 1 creates transaction on device with wallet details of user 2. Transaction encrypted using user 1 private key. Okay, so that's the first part. How many marks is there? 4 marks. Okay, so then this is broadcast to computers on the blockchain.
My favorite teacher.
What are you doing? Because I'm recording a video for a lesson. You're all right. Have you got a lesson now? No. Get out. Okay. So step 1, step 2, step 3, step 4 is broadcast. This transaction is broadcast to computers on the blockchain. And then this is transaction is verified by minus, maybe minus, I'm going to put not actual minus of code, but I'm going to do this, by minus. It will basically solve problems. As minus. Transaction is verified by minus, has user 1, basically, has user 1 got correct funds. Okay, so verified. Valid transaction is grouped with other transactions on a block. Okay, transaction. Okay, transaction. So once this is full, it's added to blockchain. Okay, so this block, let's say that's gone to there, and then added to blockchain, connected to previous block using hash. Using some kind of cryptography, using hash. I'll put in there cryptography. Okay. I'm just going to mention here POW. By doing this, they create something called a proof of work. I don't know how much detail we need to go into this, Okay, so it's added to the blockchain, connected to previous block using hash cryptography. Then this creates a secure ledger. It can't be tampered with. Secure ledger. Made it as it's like a book. Okay, so it's recorded, yeah, can't be tampered with, creates a secure ledger. Once all this is done, finally, transaction to user 2's wallet. Okay, so I think I've gone overboard, but if I try to zoom out a little bit, yeah. Okay, so user 1, so draw an annotated diagram to show how a payment transaction is made using digital currency and blockchain. So user 1 wants to send digital currency to user 2. User 1 creates a transaction on their device with wallet details of user 2. Okay, transaction is encrypted using user 1's private key. Yeah, then once this transaction is completed and been encrypted, it's broadcast to computers on the blockchain where miners are working, a little miner here, to verify if this transaction is legitimate, if the user 1 has got sufficient funds to carry out for this transaction, and a proof of work is generated. The miner has to solve some kind of cryptographic puzzle. Then, once the transaction has been validated, it's grouped with others on a block. Okay, that block is then added to the blockchain and connected to the previous block, yeah, using hash cryptography. This creates a secure ledger, and then once this ledger has been created, then that transaction can be sent, that digital currency can be sent to user 2's wallet. Yeah, for 4 marks. I think that's completely overboard. I've not checked the mark scheme, but yeah, that's basically how blockchain transactions work. Okay. Then finally, question 9, just to finish off. Let's zoom in on this. Nice and easy one. A doctor's surgery has an expert system that helps diagnose the illnesses of patients. So we're moving on to sort of artificial intelligence. Yeah. Complete the paragraph about the operation of the expert system. Use the terms from the list. Some of the terms in the list will not be used. Okay. Some terms may be used more than once. Oh my word. So let's go here. An expert system is a type of artificial binary central processing unit, data inference engine, interface, knowledge base, primary storage, process, read-only memory, rule base. These, rule base, knowledge base, and inference engine, are probably artificial. I'm looking at potentially the ones that we're going to be using. So, an expert system is a type of what intelligence? It's obviously going to be, we know this one, fish. Pretty awful. So I'm going to tick that one, but I'm not going to cross it out because it might be used again. The doctor will type data about the symptoms of the illness into the what? Type them into the computer, type them into the knowledge base, the inference engine, the rule base. It's going to type it into some form of, just looking at this, it's going to type it into some form of interface. Yeah. The something will decide which questions to ask the doctor. The something. Is it going to be the knowledge base? Is it going to be the inference engine? It's going to be the inference engine. Okay? The inference engine. Okay? So type in the symptoms, yeah, into the interface. The inference engine will decide what questions to ask the doctor based on those symptoms that the doctor put in. It will do this by linking the facts in the, it's got to be this one, in the knowledge base. Okay? To the, what have we got? We've used inference, we've used knowledge base, we've used inference. Yeah, I think it's going to be rule base. To the rule base. Okay? Yeah, so we've used that one as well. Now then, there's something we'll decide on the diagnostic, the diagnosis, and this will be outputted on the, well, what have we got? Outputted on the, so think, this is where we're going to be looking again. There's something, so it's going to go backwards, yeah? So now, again, the inference engine, so we use that twice. The inference engine will decide on the diagnosis, and this will be outputted onto the, it's not the screen. If the doctor's using the interface to input it, it's going to have to be outputted to the interface again. We can assume there's some kind of tablet. It's got an input and an output. Okay, 7 marks. So an expert system is a type of artificial intelligence. The doctor will type data about the symptom of the illness into the interface. The inference engine will decide which questions to ask the doctor, sort of the artificial intelligence bit. It will do this by linking the facts in the knowledge base to the rule base. The inference engine will decide on the diagnosis, and this will be outputted back through the interface. Okay, the expert system has the ability to automatically adapt its own processes and data. Give the name of this ability. So it's a machine that is learning, adapting, the word for sort of learning, its own processes and data. So this is called machine ML, machine learning. Okay. I recommend reading up on artificial intelligence, expert systems. Yes, it will. I'm sure this will come up on a lot more exam papers in the future. This is current, current information. Okay, that is it. That is it for this paper. So thank you very, very much indeed, and I'll see you next time. Bye for now. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.